In this lesson, we'll explore solving a system of equations. There's going to be 3 different methods we're going to use to solve a system of equations. But the logic is just this. We might have 2 different equations, both with y and x in there, and we want to try to find an ordered pair, an x and a y, that satisfy both equations. So graphically, if you're looking at a system of equations, one might have one equation that might graph out like this, another one that might graph out like this, and your solution is going to be where they overlap at the intersection. And in this example, we're looking at a system that has one unique solution. And this will happen whenever you have intersecting lines. There are 2 more cases that are possible, which we'll explore towards the end of this lesson. One case is what happens if our 2 lines are parallel. If our 2 lines are parallel, then there is not going to be any solution because there's no point where the 2 lines intersect. So there's going to be no solution in this case. Our third scenario is what happens if we have one line that looks like this and then another line right on top of it. It's exactly the same line. Well, in this case, since it's the exact same line, anywhere along this line will be a solution. So there's going to be an infinite number of solutions. This is called coincident. Yeah, we'll say that's how it's spelled. And again, there's just an infinite solutions here. It is important to note that this doesn't mean that all real numbers are a solution. That would be incorrect because, like for example, a point out here wouldn't work, right? That would just be wrong. So only along this line are solutions. Just for vocabulary's sake, the case where there's no solution, we call that situation inconsistent. Okay, and for the one solution case, it's consistent, but again, there's just one solution. You don't have to create any kind of fancy name for it. So to start off, there are 3 methods for solving a system of equations. Let's see, the 3 methods that we'll explore. The first is called the substitution method. And the substitution method is a method that works well. It always works, and it's really the simplest one to understand. It's actually, you've probably already done it, you just didn't know that's what it was called. The second method is called the elimination method. And this one is often the easiest one to use, depending on how the problem is set up, but it's not always intuitive. The addition method does go by another name. The elimination method does go by another name. It's sometimes called the addition method. The third method that we'll explore is graphing. And as we saw in the first part of this video, graphing is just, you're trying to look to see where you graph your 2 lines and you just try to see where those 2 lines overlap. And while this method works and it's okay, it really does rely on your ability to graph lines very, very well, very, very precisely. So I don't really recommend this method, but it's nice to at least understand that it does exist, because essentially that's what you're doing when you're doing the substitution and the elimination method. You're looking for where those 2 lines overlap or where they intersect. All right, so continuing on, first we're going to explore the substitution method rather. So with the substitution method, let's explore a pretty simple system of equations. I like to indicate that we're dealing with a system by using a curly brace on the left, because the idea is that these 2 equations aren't acting independently, they're acting together. Our first equation is 4x minus 2y is equal to -2. Our second equation is y is equal to x plus 3. Okay, so one of these equations is in slope-intercept form and one of them is in standard form. That doesn't really matter for the substitution method. However, it is something that you're going to want to pay attention to if you're dealing with the elimination or addition method. Okay, so to solve this, what you want to do is you want to solve for one of the equations. We've actually already done that. We've already solved for y. It's that's how the problem was represented. So we already have this already solved for y. What you're going to do is you're going to take that and plug it in to the first equation for y. So instead of dealing with 4x minus 2y equals negative 2, you're going to do 4x minus 2y equal, well, instead of y, you're going to do x plus 3 equals negative 2. So we have to plug it in. All right, so let's do that. So we'll rewrite our first equation as 4x minus 2 instead of y, plug in x plus 3 equals negative 2. Okay, next we just want to distribute the negative 2 and solve. So we have 4x minus 2x, remember distribute the negative, so we get minus 6 equals negative 2. So to solve this, combine like terms, and we get 2x, because 4x minus 2x is 2x, minus 6 equals negative 2. Add 6 to both sides, you get 2x equals 4. Divide by 2, and you get x equals 2. All right, so that's only part of our solution because we also have to solve for y. Remember, we need an ordered pair solution. So we know that y is equal to x plus 3. So let's just plug in our value for x, and we get y is equal to 2 plus 3, which of course is just 5. So that means our solution to this first problem is just 2, 5. Remember, you got to list x first and y second for an ordered pair. All right, for the second one, we have 5x minus 3y equals negative 4, and our second equation is x plus 2y equals 7. This one's a little bit more difficult for using the substitution method because we haven't solved for one of our variables yet. So we just look at the equations and figure out which variable will be easiest to solve for. I think it'll be x in the second equation. So let's solve the second equation for x. So we have x plus 2y equals 7. Subtract 2y from both sides, and you have x equals 7 minus 2y. So we can take that answer and plug it into the first equation, our other equation, and figure out what x is. Figure out what y is. So we have 5 times x, but x is just 7 minus 2y, minus 3y, equals negative 4. Distribute the 5, and we get 35 minus 10y, minus 3y, equals negative 4. When we combine like terms, we get 35 minus 13y equals negative 4. Let's subtract 35 from both sides. So this way we get all of our y's on one side and all of our numbers on the other. And we get minus 13y equals minus 39, or negative 39. Okay, so now let's finish this. So we have negative 13y equals negative 39. If we divide both sides by negative 13, the negative 13's cancel out. Our negatives on the other side cancel out. And 39 divided by 13 is just 3. So we get y equals 3. So we know what y is. Let's figure out what x is. Well, the easiest way to do that would be to plug it in to our equation over here, since we've solved for x already in that equation. So we're just going to do x equals 7 minus 2y, but instead of y, let's plug in 3. So we get x equals 7 minus 6, which is just 1. So our solution for this one would be 1, 3.